During his miracle year in 1665, Newton discovered calculus, developed his law of gravitation, and performed critical experiments in optics. Newton later developed the first Newtonian reflector. Space. Extending Galileo's groundbreaking work in dynamics, Newton published his 3 laws of motion and the law of universal gravitation in the Mathematical Principles of Natural Philosophy in 1687. With these laws, one could explain and predict motion not only on Earth, but also in tides, comets, moons, planets. In other words, motion everywhere. So today we're going to talk about some of the math that Newton discovered along with his laws of motion and the uniform law of gravitation. We're going to focus on the derivatives and the fundamental theorem of calculus as it applies to derivatives. Now this equation looks a little complicated. It turns out, for the purposes of core physics, we can actually take a much simpler approach. Please note that it is often the case that in mathematics or in higher division physics, we actually go back to this equation and extend it to other applications. So there's 2 things that I would like you to remember before we get started into the math. First, derivatives are tantamount to slope. Essentially, it's the rate of change of any function. Second, dy and dx are independent quantities. We can multiply and divide them just like other quantities in an algebraic expression. So let's start with a basic line. Here we have a line plotted on an xy coordinate system. The slope-intercept form of the equation for a line is y equals mx plus b, where m represents the slope and b represents the intercept. Here, the letter b is 0 as the line passes through the origin of the coordinate system. If we want to find the slope from the points of the line, if we happen to know them, we can look at the change in y or the change in x and calculate the slope. Basically, the derivative does the same thing. It looks at a little bitty or infinitesimal change in y divided by an infinitesimal change in x and says that's now the slope. Mathematically equivalent for a line. But what happens to b in this equation from the original equation for y equals mx plus b? Well, it turns out the derivative of a constant is 0. If I come over here to now an equation that is no longer a line, in this case it happens to be a parabola, with an equation y equals 3x squared plus 1. The question is, how do we calculate the slope of y? It's not as simple as a straight line. In fact, it's changing at every point along the way of the function. The answer is we're going to apply the power rule for derivatives. We know that dy dx, or d by dx of ax to the n, is equal to, in this form, I take the exponent and I drop it down to the front, hold the constant, write down my x, and then subtract 1 from the exponent. To make this happen for the original equation, start out by writing dy dx equals insert the original equation, and then apply my power rule, noting that the derivative of 1 is 0 because the derivative of a constant is always 0. I bring down my power, keep my constant, write down x, and then reduce the power of x by 1 according to the power rule. In the end, the derivative of the original equation is now 6x. So before we close our discussion, I'd like to point out one subtlety about what you see in the parabola and what you see in the line. As it turns out, our equation y equals 3x squared plus 1 is always positive, noting that all the points of y stay above the x-axis. But if we look at the derivative, 6x, it can be both negative and positive. It turns out that our slope from the y-axis extending out to the positive x direction is always positive, but our slope going from the y-axis out towards negative x is always negative. If we look at our plot of our line now, we note that the equation for the line, when you plot it, has positive values of y from y out to positive x, and negative values of y from y out to negative x. It turns out that this derivative, 6x, If you compare that to y equals mx plus b, note I have an intercept of 0, I have a slope of 6, and an equation. So a line is the slope of the parabola. And now you're back from outer space. Sad look upon your face.